Hello everyone, and welcome to this introduction module to the Procedural Asset Production Masterclass. In this video, I'd like to discuss flags and badges in Houdini and how we can use them to both read and set the states on our nodes. So let's have a look inside Houdini. So the first thing I'd like to talk about is flags. If we hover over any node in Houdini, you will notice this little radial menu appearing. And this radial menu contains the most common flags that we can set in Houdini, namely the render flag, the template flag, the bypass flag, and the lock flag. Now there are other flags available to us as well, and before I continue, I just want to show you the list view. And the list view allows us to see the states of all the nodes currently inside our network. To open up the list view, we can click this button up here at the top of our network editor, or we can press the hotkey Shift-T. Now the list view will show you all the nodes in the current level of our network, and it will also show you all the flags that are being set on those nodes. However, the list view also has the tendency to overlap the network view completely. So if we don't want that, in order to see both our network view and the list view at the same time, we need to open up a second network view, specifically for the list view. So I'm going to close it in this network editor. And then on the top here in my parameter pane, I'm going to click on the plus icon and open up a new network view. Now this new window is currently pinned in place. This means that whenever we change our network view in any other location in Houdini, this one will stay in place and won't move along. However, because the bottom menu isn't pinned, if we were to make changes in the pinned menu, then Houdini will actually update the other unpinned network editor along. So basically this one will sync to that one, but the top one won't sync to the bottom one. If we want both of them to sync, we need to actually unpin the top network editor. So now that both panels are synced, let's go to the top and click on the list view to open up the list view for all of the nodes in this part of the network. And if I were to navigate to different parts, you'll see that the list view moves along, so we don't have to update it manually. Let's have a look at the different nodes in the list view. Let's look at the first set here. And these two relate to the current render flag being set. Now in general, when we move our render flag around in our network editor, both the render flag and the view flag are automatically enabled. And in general, I just keep these together. I don't mess with this. Also, you don't really have to mess with it because both of them actually relate to what's currently in my scene being viewed. And that's exactly what the render flag does. It displays what's currently being selected in your network. While you can select another node in the viewport, only the node that currently has the render flag is being displayed. We can maybe create a wireframe of an existing node if we have a handle selected, but this is just a representation of our current selection in the network editor. And it automatically gets undone the moment we select a different node. Now render flags are also used in Houdini to determine what node outputs data outside of the current network, with the exception of output nodes, which actually override the render flag altogether. So as we saw in the last video, if we go inside of a subnet and we create an output node, that output node will override all the render flags in this network. So if I select this sphere as my render target and I go outside of this network, the output node still overrides my render flag altogether. But if I were to get rid of this output node and then go outside of the subnet, you see that now outside of the subnet our render flag is taken over and we still see our sphere, even though we're actually inputting our grid from the top. So that's an important thing to know. Output nodes override render flags, but under any other circumstance, the render flag determines what's currently being rendered. Now the next flag that I want to talk about is the template flag. If we hover over a node, we can find it as the pink ruler shaped icon. Now the template flags in Houdini act very much like the render flag, except it doesn't force a node to cook out of a network. And unlike the render flag, we can actually have multiple template flags activated on a node. But other than that, they do the same things. Just like render flags, they force the network above those nodes to cook. So if you have a render flag set on any other part of your network, it will create either a wireframe mesh of whatever you have templated, or if you enable the selectable version, either by clicking on it in the list view or by clicking on it with control click, you will create a separate object in your viewport, and it will force whatever nodes are above this node to cook as well. So they will be evaluated. Now we can actually view multiple nodes at the same time if we hold Shift and then click on the render flags of these other nodes. And as you can see, I can highlight multiple nodes in my network, even though these aren't actually part of whatever is currently being outputted out of this geometry container. If I go outside the geometry container, even with all these objects templated, they won't be there when we view the output of this container. So the template flags are local. We can only see them when we are inside of a network, but they are permanent as long as they are selected. And unlike the selection that we made earlier with the handle, they don't go away when we select something else. And this is important to know because if you were to template objects in your scene, they will force whatever is above that network to cook. If I template the bottom of this network here and highlight the mountain node over there, then it will still force whatever changes are being made here to cook. So keep that in mind. If you ever have random cooking behavior, you might have a template flag set. Now template flags are really easy to clean up. All you have to do is just click on the same node you're rendering, and if a template flag overlaps a render flag, it will simply cancel it out, because you cannot display a template geometry while the same object is being rendered. It doesn't work. Okay, so let's move on to the next one. The next flag that I would like to talk about is the bypass flag. And the bypass flag simply bypasses this node altogether. It's no longer going to be evaluated, and Houdini will just pass whatever data comes in from the top straight through the node and treat it as if it wasn't actually there. So if I were to bypass this entire subnet, for example, then whatever this subnet was doing will no longer actually be applied at the end of our network. This is very useful. If we ever need to turn off parts of our network, we simply have to select the nodes and turn off the bypass flag. Do keep in mind where your nodes are being bypassed, but it's easy enough to spot because of the big yellow icon and of course the grayed out nodes. If you want to at a glance see what nodes have a particular flag, just open up your list view and that will allow you to find it. So the next flag I want to discuss is the lock flag, and it's shown as the lock icon up here in the list view, but if we go over to a node and look at the radial menu, it's actually displayed as a snowflake. Now the lock flag, if we flag this, will store whatever is currently being held in memory from this node and lock it in place. The lock flag essentially prevents this node's memory from being altered, and it is then saved to the scene file or the asset whenever we save either one. Now this can be useful in case we need to debug something or take a piece of geometry like this terrain, for example, and move it somewhere else. I can make a copy of this null node and paste it somewhere else and simply disconnect it from the network, and the lock flag will keep its data in place. In fact, let me just clean up these flags a bit, and as you can see, even though there's no input currently coming into this null node, the lock flag has kept the data where it's supposed to be. If I were to save this scene file, then if I open it back up again, the data will still be there. But the lock flag has a couple of other things as well. If you were to lock a node and you feed it different data, like say I feed it this sphere, it also won't update. So effectively we've created a breakpoint in the memory of our node chain of sorts. You want to keep this in mind because this increases the memory of your scene file or your assets. Effectively, whatever geometry we're currently storing inside of this node as locked data is no longer stored in the memory of our computer, but instead it's being stored in the scene file. And if I grab my information panel, which we can get by clicking the info button on the left of this radial menu, and let me just quickly lock this so it doesn't go away when I click somewhere else, we can see the memory footprint of this node. Now this is all the data that's currently being stored inside this node. Effectively, the entire mesh, its attributes, its groups, and all the other data that's present inside this node takes about 3 megabytes. If I save my scene with this node locked, it will add about 3 megabytes to my scene file, plus minus some compression. So by locking data, we are locking it in place, we prevent it from changing, but we might also bloat our scene file and our Houdini tools, our HDAs. Now, in general, you don't want to lock your data inside of a node, especially when you're going to hand it off to other people because of this reason. But locking data can be very useful when you're debugging or certain situations. So, speaking of flags that affect memory, there's another flag that affects memory on our nodes, and that is the unload flag. And the unload flag effectively disables the memory caching of that node, forcing it to reevaluate every single time a node below it asks for an update. Now, before I do this, let me first disable the lock flags on these nodes. And as you can see, it actually triggers a warning, which is useful because we might not want to get rid of our node caching, our locked cache. But in this case I do, so let's get rid of them. And next, let's grab these nodes and move them over, make a little bit of space so I can highlight them. And then I want to go over to the top of my screen, and up here we have the performance monitor. Now I'm going to grab this and tear it off, so click on the pane options and tear off the pane. And this gives me the performance monitor. And the performance monitor allows me to see the changes that nodes make whenever they cook. So if I grab one of my nodes here and I turn on the recording feature, I can then make some changes in my network, and you can see every single change that Houdini has made is being recorded over here as time. So this is a useful way to figure out how long each node took to cook. And by default, it will show it as a heat map. So you can see the heaviest node that took to cook was the mountain node, then the sphere, and finally the null node, because the null node doesn't do very much. The mountain node is definitely the heaviest node in this bunch. So next, let's see what happens when we reevaluate our mountain node over here. Let's clear the performance monitor's recording. Click on this button, and this will remove the highlight. And now, like I showed you in last video, if we move the mountain node around, change only the nodes down the network, then all the nodes above it, such as the sphere here, will simply read from their cache, and they don't need to be updated. But if I take my sphere and I go to the list view, and then I click on the unload flag, then now you'll see how the unload flag has been enabled on this sphere, and it looks like a little garbage can. And this means that the sphere, in this case, will no longer store whatever changes it's cooked into memory. So it will have to be reevaluated every single time we cook the nodes below it. If I reevaluate my mountain node this time, you see how the sphere also is forced to update. Now the unload flag can be useful in case we need to make a network more memory efficient. but because it does cause all the nodes to reevaluate that have the unload flag enabled, it can cause the nodes to take longer to cook. Now the last flag that I want to discuss is the highlight flag. And the highlight flag is basically a flag that allows us to view whatever we currently have in groups. It highlights parts of the geometry on our screen. And I haven't really discussed groups yet, but if I create a group node and I place one down, it will automatically have its highlight flag enabled. So if I click on my sphere, then by default it will try to group everything, and it will highlight it whenever we have our group node selected in our screen. If I untag the highlight flag from this group node, then it will no longer be visible in my screen. So that's what the highlight flag does. Now that pretty much covers all the flags that we can set in Houdini and how they relate to their individual parts. And the next thing I want to discuss are badges. So badges on nodes, we can view them when we look next to a node, such as for example the mountain node and the null over here. And they show us at a quick glance the state of a node. If we want to see the badges on some of our nodes, we can do that by pressing the D key, and this will open up the network view display options. If you go over to the badges tab, then here we can see a range of badges that will be available on our nodes depending on the situation that node is currently in. Up top here we have the error badge, which we've already met in the last video. We also have the warning badge, and there are several other badges here as well, like the locked badge that we already saw and the unload badge. But I'll quickly just go over every single one of them and in what context we can find them. So the first badge that we have here is the error badge, and the error badge will appear whenever Houdini's nodes cause an error. And when an error occurs in Houdini, it means that the node can no longer evaluate and our node breaks. When this happens, if this happens in your tool, it will break your tool. So you want to avoid generating errors because you can't recover from an error. So let's go ahead and generate a couple of errors. The first error that we can make, we've already seen. If we take a part of our network and loop it in on itself, it will generate errors all throughout that network. And that's because these nodes are trying to reevaluate themselves. If we click on the node, you will see that the info button has now changed to a error button. If we click on this, and let me pin this again, then now it says infinite recursion in evaluation, and then it tries to tell you which node it thinks caused the recursion. Though really what it's just telling you is that its input, in this case the mountain node, has an error. And this is one error that we can generate. We can also drop down a file node, for example, and the file node, if we place that one down, asks for a certain kind of geometry. Now if I were to load the default geometry, which is the cube, then by default this node works. But if I remove the geometry from here or give it an invalid name, the node will also generate an error by default. And if I look at its error message, it says please specify a geometry file. Now we can actually disable this on the file node. If we go to its missing frame parameter, we can set it to instead generate no geometry. And now instead the node will give us this little warning badge instead. We'll get to that in a minute. Now errors in Houdini will generally tell us where the error occurred, and the only thing you really have to do is go up to the node that has the error and look at it. So let's say I grab this set of nodes here, and let me add a transform node in the middle. And then instead of typing in these fields some kind of number, let's feed it some text. The transform node cannot deal with text in a float value field. So it will give us an error telling us that unable to evaluate the expression, bad data type for function. Okay, so it tells us that the transform1 t value has a bad piece of expression in it. And now you can also see that the entire node network from the render flag up has turned red. So it's easy to spot if you have an error in your network. Let's take this off and let's have a look at the next badge that we can view. And that is the warning badge. Now the warning badge is like an error in that something is going on that Houdini thinks isn't right. But unlike errors, it doesn't actually cause the network to fail. Let me lock this so it stays in place. Like I showed you, this file node, for example, without the missing frame set to report error, will simply give us a warning. And this means that right now this node isn't outputting any geometry. And under normal circumstances, this is fine. However, if other parts of your network are relying on this file node to output geometry, then it might still cause a problem for us. So let me demonstrate this. I'm going to grab this window, move it out of the way. And then if I grab my box over here, we can use the input on this box primitive to match its shape to whatever geometry we're providing. So if I grab this torus over here and I plug it into the box, then the box will take up the general shape of the torus, basically its bounding box. It's a good way to actually make a bounding box. Now, if I were to plug my file node into this, when the file node actually doesn't have a file, but it's not set to generate an error, instead what it will do is it will force this box to basically have no space at all. There's no file to load, so the box doesn't know what bounding box it needs to generate, and now we basically just have a dot in the middle of our screen. On the other hand, if I were to go in here to the file node and revert its default value on the file path, now it's generating its default geometry, and now it can evaluate. So if we were to ignore the warning on this file node, we will simply end up with 0 geometry. Now there's one other way that I want to show you that we can generate a warning. And that's what happens when we take some objects, like this box and maybe this torus, and I merge them together. And under normal circumstances, this would not generate a warning because both geometry are basically the same. If I look at my box under this info panel, we can see its attributes right here. And I'll talk more about attributes in the next video, but as you can see, both of them share the point attribute, indicating the position of the points on this object, as well as on the torus. And if they are merged, then both will share the point attribute here. But if we were to create an attribute on one of these objects, like a color attribute or a normal attribute, and we can do that easily by creating a color node and maybe a normal node, then now the normal node over on the box has generated a point normal attribute for us, and over on the torus we now have a point color attribute. But as you can see, both pieces of geometry have different attributes present. Now the merge node will tell us that there's a warning. If I look at the warning, we can see that there's a mismatch of attributes present on the inputs of the geometry. In this case, it tells me that it has both a mismatch for the normal attribute, or N, and the color attribute, CD. Now I'll leave it there for now, but this basically highlights the warning badge. The next badge I want to discuss is the comment badge. And the comment badge is pretty simple. If we grab a node and we click on its info panel, then down here we have the comment field. And we can type comments in here to leave them on our node so we can later look them back. If I were to type, say, hello world, this is a comment on the node. And if we click outside this window, it will have now left a comment on this node. Now if we want to view the comment next to the node as well, we can go to the info panel and click the show comment in network button. And now, as long as you are zoomed in close enough, you'll be able to see this node has a comment. So that's fairly useful. But if you don't have this enabled, then the comment badge allows us to see this at a glance. So the next badges in the list are the one for the lock state as well as the unload state. So we've already seen that. If we grab a node and we lock it, then it will get that little snowflake icon. And if we enable the unload flag on this node, we will get the unload icon over there. So that's straightforward, we've already seen that. The next two flags over here aren't as important. They're mainly useful for debugging. So the first one allows us to see if a node has data being cached to memory. So if I enable these by clicking on it, by default they're disabled, we can see that every single node in my network currently has data being cached. This is useful if you're trying to debug your network when you're using unload flags. But other than that, I don't think you have to turn it on ever. Next, we have the ability to see if a node has to be cooked, because a change was made on a node, but it was never recooked. So if I click on this and I enable it, we can see that this part of my network here might need to be recooked because something was changed about the sphere node and it was never reevaluated. So if I render these and I make sure that it also points towards the sphere, then this goes away. I don't tend to use this, but it's there if you need it. The next two are specifically meant with digital assets. And digital assets are nodes we haven't completely looked at yet, but Houdini does come with some digital assets, as does the labs toolset. If I place a mountain node down, you'll see that it comes with a little lock icon, very similar to this one. And this means it cannot be changed. This node is matching the definition of its library on the hard drive. Now this is important. You don't want to change native Houdini nodes. But if we unlock this node, right click it and say allow editing of contents, then it will get a large unlock icon. And this means that we can actually change the node. If we were to make changes to the node at this point and save it, then we can lock it again and it will match the new changes saved to disk. But like I said, don't go and change Houdini's native digital assets. It will cause a lot of trouble for you because, well, you don't want to modify those libraries, ever. But we'll go into digital assets later. For now, there's only a couple more badges that I want to discuss. The first one is the time-sensitive badge, indicated by a little clock. And this happens when we install a time-sensitive variable to one of our nodes or somehow link it to our timeline. So you can see that this mountain node over here has been linked to the timeline, and when I move my timeline around, the offset on my node also changes. So whenever a node is linked to the timeline and all the nodes below it, they will get this clock, meaning that they're time dependent. There's only really one other badge that I want to discuss, and this involves compiling. Now we won't go into compiling in the introduction module just yet, but compiling is a process in Houdini to speed up the evaluation of nodes by allowing the nodes to be multi-threaded and be more efficiently stored in memory. But there's some nodes in Houdini that cannot actually be compiled. There are some nodes like, for example, the polyextrude. If I look for that one, the polyextrude cannot be compiled. The attribute transfer also cannot be compiled. And when you put nodes inside of a network and you try to compile that using the compile block, then this compile block will tell us, well, I can't compile that because it's not supported for compiling. That's pretty much all the badges that I wanted to go over. There are other badges as well, but I'm not going to go into those here. So that was a bit technical about flags and badges and how we can use them in Houdini. But in the next video, I would like to continue and talk about the topic of geometry, as well as attributes and how they relate to geometry in Houdini. So thank you for watching this video, and have a good one.